Hello everyone. In this lesson, I am going to tell about polar and non-polar bonds. Because in the previous lessons, you have studied how the reactant, depending upon the type of reactant, how the reaction going to vary, how the cleavage takes place, how the intermediates have been formed. So the attacking reagent will go and attack the substrate. The substrate may be polar and non-polar. That also going to affect the reaction mechanism, the path in which the reactants are getting converted into product, and also the velocity or rate of the reaction. So in this lesson, we are going to know the definition and example for polar and non-polar bonds, how we are going to classify them based on what values, based on electronegativity and based on dipole moments values. We can easily classify them. Experimentally, we can find out whether they are polar and non bonds. Polar covalent bonds, as the name indicates, they are polar in nature. Polar means they are going to have two poles in them. So such we are going to call it as the polar covalent bond. If the covalent bond is formed between the two different atoms, then the shared pair is displaced towards the more electronegative atom, causing the greater concentration of electron cloud around the more electronegative atom. Such covalent bond develops some ionic character and is called as the polar covalent bond. Unequal sharing of electron. When you consider the heteroatom heteromolecules, so molecules which are made up of two different atoms. For example, when you consider H and Cl is more electronegative in nature. It has the tendency to pull the electron. So as shown in the picture, there will be unequal sharing of electrons will be there. Since chlorine is more electronegative in nature and also it going to have more number of electron compared to that of hydrogen, the less number of electrons will be there in H side and more number of electrons will be in the chlorine. Thereby, when they do the seesaw or when they do this type of pull and push exercises, it will be more towards the more electronegative atom. This leads to some sort of ionic character, and such type of bonds we are going to call it as polar covalent bond. For example, when you consider water also going to have two poles. The hydrogen will going to have positive pole and oxygen will going to have a negative pole. They have not completely detached, but they in the molecule only they going to have certain form of ionic character have been developed in that molecule. Such molecules we are going to call it as a polar molecule. Similarly, ammonia also going to have the polar molecules. Hydrogen sulfide is also a polar molecule. The electron density is distributed asymmetrically, not symmetrically throughout the molecule. Such type of molecules we are going as polar molecules. Similarly, non-polar molecules. Similarly, homoatomic molecules will going to have. They're going to have same number of electrons. They're going to have the same electron cloud. Thereby, they can be easily uniformly distributed around the two atoms. Such covalent bond is called as the non-polar covalent bond. If the covalent bond is formed between the similar atoms, the shared pair of electrons lies almost at the center. The electron cloud is uniformly distributed around the two atoms. Such covalent bond is called as non-polar covalent bond. Equal sharing of electrons takes place and they do not contain any poles in them. Such we are going to call it as polar covalent bonds. Example, chlorine, boron trifluoride, hydrogen, all these are non-polar molecules. Electron density is distributed symmetrically throughout. Similarly, when you consider the different electronegativity values of the atom participating in the bond, that also lead to the unequal distribution, that also makes the ionic character in a covalent bond. For example, when you consider HCl, the Cl will going to have the higher electronegativity compared to that of hydrogen. Thereby, there is a lot of difference in their electronegativity values. Because of that, there will be a positive or the ionic character that has been developed in HCl. In comparison to that of hydrogen, they are going to have same electronegativity value. Therefore, they are going to have the polar. So, there won't be any unsymmetrical. There is no ionic character. There is no poles in them. Such will be there. Classification of bonds. Determination the type of bond between the two atoms by calculating the difference in electronegativity values between the elements. The bigger the electronegativity difference is, the more polar the bond. Non-polar covalent bonds, if the electron difference is between 0 to 0.4, they are called as a non-polar bond. If the electronegativity difference between two atoms which are involved in chemical bonding is 0.5 to 1.9 polar covalent bond. 2 to 4 then it is called as bond. So electronegativity values also going to give us the value. For example, electronegativity values are nitrogen 3, hydrogen 2.1, oxygen is 3.5, chlorine is 2.5. Where I am going to get these values? When you go to periodic table, each and every element in the periodic table, it has been already they have calculated experimentally, they have determined using the X-ray diffraction studies, spectroscopic studies, they have already determined the values. So it doesn't have any units. If we are going to have the numbers, electronegativity values, electronegativity numbers, we are going to have in a periodic table. For example, when you consider H and N, the bond difference is 0.9. Similarly, H and O 1.4. Then HC 2 is 0.4. So based on that, we are going to say that which one is more polar. All these are polar in nature. Between them, which is more polar? So that is the order is HC, NH and HO. So like this, we'll come to know from the electronegativity values, we can easily classify them into polar, non-polar, ionic. Similarly, another parameter we can consider in order to say whether the given molecule is polar or non-polar, that is dipole moment. The degree of polarity of the bond usually expressed in terms of dipole moment, which is a product of magnitude of charges and distance between them. So it is d by is a unit. So magnetic dipole moment is mu delta into d, where delta is the angle of its sort of charges, magnitude of charges, and d is the distance between them. So 1 d is equal to 3.34 in 10 to the power of 34. So dipole moment is a vector quantity and indicated by the arrow mark pointing towards the negative end. The greater the dipole moment, more will be the polarity of the bond. Dipole moment is different in different covalent molecules. For example, you know that already HCl is a non-polar molecule. Here, the polarity is more towards the chlorine. Therefore, the arrow mark is indicating towards the chlorine. Similarly, when you consider the different electronegativity values of the atom participating in the bond, that also lead to the unequal distribution, that also makes the ionic character in a covalent bond. For example, when you consider HCl, the Cl will going to have the higher electronegativity compared to that of hydrogen. Thereby, there is a lot of difference in their electronegativity values. Because of that, there will be a positive or the ionic character that has been developed in HCl. In comparison to that of hydrogen, they are going to have same electronegativity value, dipole moment. Similarly, when you consider the carbon tetrafluoride, that also the carbon at the center, and it has been directed in 4 different directions. Therefore, net dipole moment will be 0. But when you consider the chloroform with the formula CHCl3, it going to have, you see the indication where it has been indicated. In the case of CCl4, it has been indicated towards the chlorine, whereas in the case of CHCl3, it has been indicated towards the oxygen, indicated towards the carbon. So carbon will going to have the more electronegativity than that of the hydrogen, whereas in the case of chlorine, it is all the 3 are in the direction towards the chlorine, whereas between C and H, it is towards the carbon. Therefore, it is polar in nature. It is going to have some dipole moment. Similarly, when you consider the geometrical isomers of butene, trans 2-butene is non-polar, whereas cis 2-butene is polar in nature, because again the direction, in the case of the trans, the 2 CH3 groups are in the opposite direction, therefore it get cancelled, whereas in the case of the cis, they are in the same direction, it is pointing towards the carbon, therefore it going to have some. So this is the way I can easily tell whether the given molecule is polar or non-polar based on their electronegativity values or based on their dipole moment. If they have a dipole moment, then we are going to say that they are non-polar they are polar in nature. Dipole moment is 0, then we are going to call them as they are non-polar in nature. For example, when you consider the diatomic molecules like HF, they are going to have 2 poles in them, and the dipole moment is 1.9 d. Similarly, HCl 1.08 and HBr 0.79. Similarly, not only diatomic molecules, even the polyatomic molecules will going to have these types. For example, water 1.84D, CH3F, then ammonia 1.49D. So like this we are going to have the for polyatomic bond. So electronegativity values also going to give us the value. For example, electronegativity values are nitrogen 3, hydrogen 2.1, oxygen is 3.5, chlorine is 2.5. Where I am going to get these values? When you go to periodic table, each and every element bonds. So either based on their dipole moment, based on based on their molecule, we are going to have the geometry or the shape of the molecule. HF 1.91 linear, HCl 1.08 linear, carbon dioxide 0 bent, water 1.85 bent, BF3 0 trigonal, ammonia 1.47 trigonal, ammonia, carbon tetrachloride, xenon tetrafluoride, or sulfur hexafluoride, all of them going to have 0D, because we are going to consider them as non-polar molecules, different shapes. Thank you. All the best.